8.11 Complex Numbers, Part 4. We're continuing to write our expressions in the a plus bi form. Let's go ahead and simplify this problem here. Square root of negative 12 simplifies to negative 4 times 3. So I'm just splitting the 12 so that you see the perfect square. In this case, it's 4, and then we can do the square root of negative 4. We have 2 plus 2i square root of 3. So notice the negative square root of negative 4 is the 2i. Okay. Then we have over 2. And just like we did before, we're going to split that fraction and simplify. And that gives us 1 plus square root of 3i. I'm just going to write it like this because, again, we're trying to write a plus bi. And that's why I threw the I on the back of the square root of 3 instead of the front. Okay, next, I to the power 22. So this is a tricky one because it's such a big power. So we don't know what this simplifies to. But I do know what I squared simplifies to. So I'm simply going to rewrite I to the 22 power as I squared. Now, I'm not done because it's 22, not 2. So 2 times what is 22? 11. 2 times 11 is 22, which is the same thing as I to the power of 22. Now, I'm going to write I squared as negative 1 to the 11th power. Now, remember that odd numbers or negative numbers to an odd power are negative, and negative numbers to an even power are positives. So in this case, I know that negative 1 to the 11th power is odd. 11 is odd, so I'm going to have negative 1 is my final answer. So if we had negative 1 to the 12th power, 12 is even, and then my answer would have been positive 1. Okay, next, remember that I said you can't just multiply square root of 50, square root of negative 50 times square root of negative 3. We have to simplify first. So again, I'm going to rewrite 50 as a product of a perfect square and another number. And we have square root of negative 3. Oh, that should have been times square root of negative 3. Square root of negative 25 is 5i. And then we end up with square root of 2. And then square root of negative 3 is I times square root of 3. And now we can multiply the imaginary parts and then the square roots as well. 5i times I is 5i squared. And square root of 2 times square root of 3 is square root of 6. And again, we can replace 5i with negative 1. And our final answer is negative 5 square root of 6. We are down to our last problem. Solve the equation using the quadratic formula. And the reason we have to use the quadratic formula is because this quadratic does not factor. Now, before we do that, let's look at the quadratic formula. There's a really easy way to remember the quadratic formula, and that is, and I'm going to highlight every time I read something so you can see what I'm reading. And you can follow along in the writing. The negative boy couldn't decide to go to the radical party, so he was squared and missed out on 4 awesome chicks. And the party was all over at 2 a.m. And that is an easy way to remember the quadratic formula. So let's go back to our problem. Now, a quadratic equation is of the form ax squared plus bx plus c. That way you can see which part is your A, your B, and your C. So in this case, my A is 4, our B is 3, and our C is -2. All we have to do now is plug it into the quadratic formula. X is equal to the negative boy, which is -3, that's my B, plus or minus square root of B squared minus 4AC all over 2A. And then from here, all we have to do is simplify, and we should get our final answer. -3 plus or minus square root of 3 squared is 9 minus 4 times 4 is 16, and then 16 times, and notice we have a negative there, so this negative and this negative, that's going to become a positive, so I'm going to write plus here, okay, and then we have 4 times 4 is 16, and 16 times 2 is 32. Divided by 4 times 2, which is 8. And we're almost there. -3 plus or minus square root of 9 plus 32 all over 8.